Hello guys, let's learn how to find the inverse of a function. There are multiple ways to find the inverse of a function, and we are going to learn the graphical method and the algebraic method today. So I'll start with the graphical method. So let's take a function like y, my pen. Okay, so y equals 2x plus 1. Let's make a table of values with x and y, so we'll get a fair idea how to draw our graph. So this is my x and y. I'll choose values between -3, -2, -1. The idea is to get a proper line or whatever this graph would look like. So let's plug this into 2x plus 1. That's our y or f of x. So when I plug in -3 into this, it will be -6 plus 1, which is -5. So I'll fill these values for you for now. You just have to plug in x value into this equation and write the corresponding y value. So these are the values that I get. So let's try to plot this on the graph. So these are -1, -2, -3, and 1, 2, 3, 4. My graphics not that perfect, but you get the idea. 1, 2, 3, 4, 5, 2, 3, 4, 5. So I have to just plot these coordinate pairs on my graph. So it would be something like -3 is 1, 2, 3, 4, 5, -5, something like this. My endpoint 3 and 7 are, let's say, 2 and 5. 2 and 5 somewhere here. So I draw a line between these two. So this is my y equals 2x plus 1 line. So the idea is to find the inverse. So it's all you need to do is draw another table and mark your table as x and y. So when you find inverse, you're actually switching the values of x and y. What that means is all x values now become y in this table, and all the y values become x in this table. So all you have to do is switch x and y. So that is what I'm doing here, and the corresponding y values after we switch. Right? Now if we draw, let's take a different color for this. We'll take a red. So if we plot this particular line, it will be, the starting point is -5 and -3. It should be somewhere here, -5, -3. End point is 7, 3. We don't have so many. Let's take 3 and 1. I'm just choosing two values and drawing line between, just to make this process easier. So look how this line seems to be reflecting off of this line. So we need to find the equation of this particular one that we can do algebraically also. But the point here is, as we switch the values of x and y, we get a different line, but seems to be like a mirror image of the original one. I have the same table, same graphs given out in a neat, better way. So this is my I'm sorry, this is, I'm trying to, yeah. So this is my graph. You see the same lines, x and y values. So these x and y values have been switched here, and this is how you get the line. So if I write here, this is y equals 2x plus 1 line, 2x plus 1 line, and this we don't know yet. Or this you can easily find using its slope. Slope should be around a half, a negative half, and slope is like rise over run. So we find the slope, and using the point slope formula we can easily find the equation of this, and it turns out that this line's equation is y equals half of x minus 1. So in a bit we'll see how we can figure out this formula using inverse, finding the inverse function algebraically. But why do we need to learn this? Why are we learning inverse of functions? So this is the best application of the inverse functions. This blue curve here is our parabola. Remember, parabola is an outcome of a quadratic function, which is y equals x squared. And when we really find inverse of this quadratic function, we get y equals square root of x. So if you just take the half of a positive side of this parabola is an inverse of square root, or we can say the other way around, the square root function is an inverse of quadratic function. So this is how this concept of finding inverse is directly applied. If you see your calculator, you cannot find the functionality to find the regression of a square root function. You can't find the equation out of a given data for square root functions. So it is much easier to find the quadratic and then find the inverse of quadratic. So this is the best way to find the equation of a square root function. So let's see how we can find the inverse of a function algebraically. So we'll take the same function here, y equals 2x minus 1. Sorry, it was plus 1, I think, originally. Yeah. So y equals 2x plus 1 is our original function. And we first drew the line of it out of filling the table of values. So this time, all you have to do is switch the x and y. So in place of y, we are putting an x. And in place of x, we put a y. That's all. And then, once we switch x and y, we have to solve for y. In other words, we're trying to find the value of y by itself. So in order to do that, in this particular context, we are going to subtract 1 from both sides. Remember, we are finding the value of y by itself. So x minus 1 is equal to 2y. So 2 is now attached to y by multiplication, so we divide 2 on both sides. So y by itself is half of x. I'm splitting the 2 over x and negative 1 minus half. This is the equation of the second line. You may as well choose to write this as y equals half of x minus 1. Even that is fine. Look how it is done. Now I'm going to do a little complicated problem like a quadratic. Suppose we have a quadratic like x minus 3 squared plus 2, and we need to find the square root function. So the first step is to switch x and y. So in place of y we have x, in place of x we have y plus 2. Now solve for y. So in order to solve for y, we have to actually first get rid of what is attached to this y by a plus or minus sign. So we'll subtract 2 on both sides. So this will lead to, I'm going to write y minus 3 whole squared to my left. It will be easier because we're solving for y. So this becomes x minus 2. All I did was switch sides. So now we have a square on top of this y minus 3. In order to really get y by itself, we have to first figure out how to get rid of this 2. So the best way is to apply square root on both sides. So when we do that, we write it as square root of y minus 3 squared is equal to x minus 2 under the square root. Of course, we have plus or minus. So this square root and this square gets cancelled out. We are left with y minus 3 is equal to plus or minus square root of x minus 2. So we want y by itself, so we are adding 3 on both sides. So this will really become y equals plus or minus square root of x minus 2 we are adding, right? We got it as plus 3. So this is my square root function. I hope you get solving for y, or in other words, we are finding inverse of a given function algebraically. So this is the deal, guys. I'm going to give you a couple of problems for homework. It's for you to practice at home. So next day you need to return these questions also along with the homework that is given in the class. So I'm going to give you the original function to be y equals half x minus 3. That's a simple linear function. The second one would be y equals, I'm sorry, this is equal to sign, y equals x minus 4 squared minus 3. So please find the inverse of these two functions and bring it back for your homework. Thank you for watching. Bye.